If you want to solve the light numericals like a pro, first thing you should know is know the sign conventions. We will start with the sign conventions of concave mirror. What are sign conventions? When to give negative sign, positive sign for focal length, object distance, image distance. This is called as sign conventions. Now let us see. We are doing for concave mirror right now. The moment I say concave mirror, you have to draw the concave mirror, the first rule. Always the reflecting side should be directed towards the left side. So do not draw it in the opposite direction. And then for a concave mirror, now this part will be called as a pole, where the principal axis, what is principal axis? This line, the horizontal line, the sleeping line, it is called as the principal axis. The principal axis is the point on the mirror, and then you have focus in front of the concave mirror. For a concave mirror, the focus will be in front of the mirror, and then this is the center of curvature. In order for you to understand the sign conventions, you have to consider this whole thing as a Cartesian plane, which means you have to consider this principal axis as x-axis, and pole will turn out to be your origin. And then this concave mirror will act like a y-axis, So how you should imagine this whole setup as a Cartesian plane. The principal axis will act like a x-axis and the mirror will act like a y-axis. The pole is your origin. So anything from pole to the right side of this horizontal line, which we are now calling as the x-axis, this is all the positive x-axis. From pole towards the left, this horizontal line will become the negative x-axis. From pole upwards, this line, they will all have positive values. From pole below the principal axis, this line contains all the negative values. So, just like the Cartesian plane. So I'll just give some numbers for your understanding. 4. And then how should I draw this as? -1, -2, -3, -4, -5, and so on. Let the focus be at -3. Let the focus be at -3. Imagine. Now, let us understand the terms. What is U? U is the object distance. What is U? U is object distance. It is the distance between the object and the mirror. What is it? Distance between object and mirror. Distance between object and mirror. And where do we keep the mirror, children? Mirror is always kept on the left side, that is in front of the mirror. So imagine keeping the mirror at this position with the head pointing upwards. So how far is the object from the mirror? It is at -6. So you will become negative. You will have always negative signs. It is at a distance of 6 centimeters. And since it is on the negative x-axis, the u will have always negative sign. So I am writing always. Whatever is the condition, you will always have a negative sign. Now, focus. This is a focus. How do you define focal length? Focal length is the distance from focus to the mirror. So from here till here is your focal length, the small f. Again, if the focus is at this point, where is this point? It is on the negative x-axis. So focal length will always be negative for a concave mirror. Whatever be the position of the object, focal length will always be negative. Why? Because this focus in front of the mirror and the focal length is calculated on negative x-axis. Now, let us come to V. What is V? V is image distance. V is image distance. So, you should know, children, that concave mirror forms two types of images. One is real and inverted, and the other one is virtual and erect. Now, there are 6 positions for the object for concave mirror. Out of these 6 positions, 5 positions will give you real and inverted images. And one position will give you virtual and erect image. Now, whenever the image is real and inverted, the image will form in front of the mirror. How does it form? Imagine the image is falling like this. If it is the image is in front of the mirror, it will be inverted and it will form like this. Now, see, what is image distance? Distance from the image to the lens. Now, where is this based on? This image has the base on negative x-axis. So, again, for the image distance, I will get a negative sign. When will you get a negative sign? When the image is real and inverted. So I cannot write for V always condition. I have limitations. When the image is real and inverted, I will get a negative sign. Now see, sometimes in the last case where the object is kept between the focus and the pole, you will get a virtual image. What do you mean by virtual image? Image will be behind the mirror. So, if the image is falling behind the mirror in this case, then the image will be erect, which means the top side will be pointing towards the upwards, and then it will be virtual image. At such a condition, what is V? V is the distance between the image and the mirror. So this will be called as V, and since now the object is based on the positive x-axis, the image distance will have a positive side. So a virtual and erect image will have a positive sign for V. So we covered U, F, V. Now we should know H and H prime, or what is H? H is the height of object. What is height of object? Now imagine I kept object of 5 centimeters in front of the mirror. So height of the object is 5 centimeters. Since we are talking about the height of the object, I will see this arrow mark is pointed towards which direction? Is it pointed towards the positive y-axis or is it pointed towards the negative y-axis? So, for the sign convention of the heights of the image and the object, you should check how this object is pointed. Is the object pointed towards the positive y-axis or negative y-axis? Always the objects are pointed in the positive y-axis. Hence, positive y-axis, this is the positive y-axis, and hence the objects will always have positive sign, always. H prime, what is this? This is the height of the image. This is height of image. For this, again, for concave, there are 2 conditions. If the image is real or virtual. If the image is real, for a real image, the object will be pointing towards the negative y-axis. The object will be pointed towards the negative y-axis. Hence, the H prime will be taken as a negative when the image is real and inverted. Now, if the image is falling on the other side of the mirror, then it will be called as a virtual image. And then in this case, the image will be pointing towards the positive y-axis, and hence the height h prime or the height of the image will be positive when the image is virtual and erect. Virtual and erect. So this you should know, children, no need to by heart. Imagine a Cartesian plane. Where will be the focal length? The focal length will be in front of the mirror. The in front of the mirror is all negative x-axis. So focal length will always be negative. Since I always keep the object in front of the mirror, u will always be negative. This is u. U always will be negative. Okay. And then H, since I will be pointing the object always when I am keeping the object, I keep it in upright position. Hence, it will be pointing upwards towards the positive. H will always be positive. These are the always signs. Now, depending on whether you get a real or virtual image, some signs for V and H prime will change. If the image is real, then the V will be negative because it will be falling again in front of the mirror. However, if the object is virtual, image will be falling on the other side and it will be based on the positive x-axis. V will have a positive side. Now, how about the height of the image? If the image is real, it will be pointing downwards. Since it will be inverted image, it will be pointed downwards, which means it is pointing towards the just like the negative y-axis, and hence for a real image, h prime, which is height of the image, will be negative. For a virtual and erect image, the image will be pointed towards the positive y-axis, and hence it will have positive side for virtual and erect image. Let us solve the first numerical. Find the size, nature and position of the image formed when an object of size 1 centimeter is placed at a distance of 15 centimeter from a concave mirror of focal length 10 centimeters. So what is the first thing? It is a concave mirror. For a numerical, write always the data first. What is given? This is a concave mirror and focal length is given. So focal length is equals to 10 centimeters. And draw a small picture like this, children. This is a focus. This is the center of curvature. And you know, for a concave mirror, since the focal length is in front of the mirror, what sign it should have? It should have negative sign. Keep the negative sign in the data itself. And then he is saying the object is placed at a distance of 15 centimeters. Where will be the object placed? In front of the mirror. Hence, you also will be negative 15 centimeter, minus 15 centimeter. So, what is this 1 centimeter? It is the height of the object, which is h. And how is object placed? Always object is placed upright with the head pointing towards the positive y-axis. Hence, the object height is taken as positive 1 centimeter. First, write the data. Then they are asking you to find the details of the image. So you have to find V. So we have to use the mirror formula. What is mirror formula? Using mirror formula, you have to write like this, children. Mention that you are using the mirror formula. Using mirror formula, what is it? 1 by F is equals to 1 by U plus 1 by V. You may write the RHS as a 1 by V plus 1 by U. Since there is a positive sign in between, it doesn't matter for mirror formula. Then substitute the values. When you are substitute, take care that you are substituting along with the signs. 1 by F is minus 10, 1 by minus 10 is equals to 1 by minus 15 plus 1 by V. Now, what I will do, I will transpose minus 1 by 15 to this side. So, 1 by V is equals to 1 by 15 minus 1 by 10. take the LCM of 15 and 10, it would be 30. 15 2s is 30, so I'll multiply this numerator with 2. 10 3s is 30, so I'll multiply this numerator with 3. 2 ones is 2 minus 3. So, what does this mean? This means that 1 by V is equals to minus 1 by 30. Do I need my 1 by V value? No, I need just V value. So, I will flip the LHS, which means I'll take the reciprocal of the LHS. When I take the reciprocal of the LHS, I have to take the reciprocal of RHS as also. So, V is equals to minus 30 by 1. That means V is equals to minus 30. What does this mean? That the image is forming 30 centimeters because of the negative sign. It is forming in front of the mirror. So whenever image is in front of a mirror, for a concave mirror, what kind of a image will it be? Yes, children, it is a real and inverted image. So, write on the nature of the image. Therefore, the image is real and inverted. And how do you know that the image is real and inverted? Because of the negative sign. If V has a negative sign for concave mirrors, you should know that it is real and inverted. You write the reason also. Since V is negative. So, we have commented on the nature that it is real and inverted. He is saying position of the image. Where is the image formed? And where is it formed? At a distance of 30 centimeter from the mirror. So, the image is real and inverted and formed at a distance of 30 centimeter from the mirror. So you commented on the nature, you commented on the position. Now you have to talk about the size of the image. So now we found out V to be minus 30 centimeters. In order for us to find the size of the image, we use a different formula, which is magnification formula. M for magnification is equals to minus V by U, and we also have another formula, M is equals to H prime by H. What is H prime, children? Just in case you have a confusion, it is the image height and H is the object height. Hence, by combining both these formulae, we get minus V by U is equals to H prime by H. See, out of these four variables, except for the height of the image, I know the rest. So, I will substitute. I will keep this minus sign as it is, and then in place of V, I will substitute minus 30. This minus is there in the formula itself, children, so you have to write it separately. U is minus 15, which is equals to H prime by, what is H? H is plus 1, write it as plus 1. Minus minus will be cancelled. So 15 ones, 15 twos. So minus 2 is equals to, since in the denominator I have a 1, it doesn't matter. So what is the height of the image? It is minus 2 centimeter. What does this minus signify here? The negative sign here in these numericals tell us whether the image is real or virtual. That's all, children. Hence you have to write image height is 2 centimeters. Next one, an object 2 centimeter high. Since we are doing all the numericals for concave, the moment you see a value, write its data. So what is the data? Data is object is 2 centimeter high. It is not the object distance, children. He said height. So h, which is the object height, it is 2 centimeters. And how do you place an object? Always pointing towards the positive y-axis, and hence plus sign. An object is placed at a distance of 16 centimeters from the mirror. So now they are talking about you. It is 16 centimeter. And how do you place an object? In front of the mirror on the negative x-axis, and hence negative sign. Now this produces a real image of plus 3 centimeters high. Be careful. They are mentioning height. So what is this 3 centimeters? This is the height of the image. Height of the image, which is h prime, is 3 centimeters. And they said it is a real image. Real image will point towards the negative y-axis, and hence its sign should be minus. We have to find the focal length and then the position of the image, where the image will be positioned. See, do I have focal length? No. Do I have V value? No. Then how can I find the focal length? You have to use the magnification formula. You know, children, magnification is minus V by U, and there is one more formula. Magnification is H prime by H. Combine both of them, we will get minus V by U is equals to H prime by H. Substitute. See, do I have U? Yes. Do I have H? Yes. H prime? Yes. So if you use this combined formula, you will come to V. Minus V. We don't know V, so keep it as minus V only. What is U? U is minus 16 is equals to H prime is minus 3 by H is plus 2. Even if it is plus, keep it as a plus, children. When you are substituting, minus will be cancelled, and 2 ones, 2 eights. So V is how much? Do the cross multiplication. V is minus 24 centimeters. What does this minus sign for the image tells you? This tells you negative sign, that the image is forming in front of the mirror, which means the image is real. We know that anyhow it is real, but I am telling you so that you will understand the concept better. But did they ask for V? No, they asked for F, focal length. Now use the mirror formula. We know that 1 by F is equals to 1 by V plus 1 by U, which is, what is V? Minus 24. So this is minus 1 by 24 plus, what is U? Minus 16. So minus 1 by 16. So what is the LCM of 24 and 16? 4 fours, 4 6 24, 4 fours 16, and then 2 threes, 2 twos, multiply 4 twos 8, 8 6 48. So the LCM is 48. 24 twos is 48, so multiply it with 2. 16 threes is 48, multiply its numerator with 3. So this will be minus 2 plus into minus, minus 3. So focal length 1 by F is minus 5 by 48. What do we need? Focal length. So take the reciprocal of both the sides. So F is equals to minus 48 by 5. Do the division. Divide 48 with 5. So 5 nines 45. 3 is left over. Put a decimal, 6. So what is the focal length? Minus 9.6 centimeters. The focal length. Since the focal length also lies in front of the mirror, you have to get a negative sign when you solve the numerator. Okay, we are done with the first part. What is the second part? Now we have to find the position of the image, which means where is this image forming? Image is forming at 24 centimeters in front of the image. How else can you interpret this as? See, this is a focus, this is C, okay, this is a pole. What is the object distance, focal length is minus 9.6. So from here to here, this will be minus 9.6. So what is the distance from center of curvature to this? Double it. So it will be 12 minus 9.2. So from center of curvature to the pole, it is minus 9.2. The focal length is minus 9.6. Now, where is the object placed? At 16 centimeters. So from here, if you start counting till here, it is 9.6, and somewhere in between C and F is your object. When the object is between C and F, where is the image formed? Image is formed in front, but it will be formed beyond C. It will be formed beyond C. So how should you write about the position of the image? You should say image is formed 24 centimeters from the mirror beyond C. If you write this much, you will get the full marks, beyond C. Let me tell you a little bit more about magnification and how we can derive information from the sign of the magnification and the values. Now, what is magnification? Magnification formula, you know, children, m is minus v by u and m is also h prime by h. On solving, if you get the magnification value as positive, what does this tell? I already told you, children, that the positive and negative sign in numericals of light means whether they are real image or inverted image. It doesn't mean nothing else. So, when magnification is positive, it means it is a virtual and erect image. Virtual and erect image. When after solving, you get for magnification, you get a negative sign, which means it is a real and inverted image. Real and inverted image. And also, if m is equals to 1, on solving, if you get the value, the number to be 1, what does it mean? It means that the object height is equals to image height. That implies h is equals to h prime. When will you get where both the object and the image sizes as equal? Yes, when the object is kept at C, the image will also form at C with the same heights. So just by looking at this, you can know where the object is kept and where the image is forming, which means object at C, object is placed at C, and image also is at C. Image also is at C. And since the image is forming at C, what can you say? Is it a real or inverted image? Of course, it is a real image because C is only in front of the mirror, not behind the mirror. So, which means the image is real and inverted. Image is real and inverted. So just by the value that m is 1, you can derive so much meaning. Now, if m is greater than 1, what do you mean by that? See, you know, when the object is placed at different positions, the size of the object will be different. Sometimes the image can be point size image. Sometimes it can be smaller than the object. Sometimes it can be larger, and sometimes it is much magnified than the object. So, if the m value is greater than 1, which means the image formed has a greater height than the object height, which means h prime is greater than h. What does it mean? Image height is greater than object height. Now, from this, can we conclude whether it's a real image or inverted image? No, because both real and inverted will give you enlarged images or magnified image. So this means when m is greater than 1, it means you are getting a magnified or enlarged image. Enlarged image. So just by the number alone, you cannot say whether it is real or inverted. However, if m is, suppose I say m is plus 3, m is plus 3, 3 is greater than 1. So it is magnified. And also plus tells you that it is a virtual image. So what you can say, how can you analyze this value? Plus positive sign. What does this mean? It means it is virtual and erect image. And 3, which means it is greater than 1. 3 is greater than 1. Greater than 1. So, whenever the magnification has a value greater than 1, then what does it mean? It means that the image is enlarged. Image is enlarged. So, this is a virtual and enlarged image. So, where will you get this? This you will get behind the mirror, on the other side of the mirror. Now, let us continue. So we have studied what m is positive means, what m is negative means, what m equals to 1 can mean to you, and what if the value of m is greater than 1. Now let us see what m lesser than 1 can mean to you. Lesser than 1, it can be like m is half centimeter, 0.5 centimeter, which means m has a value in decimals. What does this mean? This means that image is diminished in size. Image is diminished in size. When the value of m is less than 1, what do you mean by less than 1? When the value of m is in decimals, you know that the image is diminished in size. And what kind of images will have diminished image? Only the real image will have diminished image. Virtual in concave will always give you magnified image. So the moment you get to know that the image is diminished, you don't even have to look at the sign. You will automatically know that it is a real image. Image is diminished in size, which means only real image gives diminished ones. So what should be the sign for m for less than 1 values? So therefore, m should always be minus and then a decimal sign. This is possible. But tell, is this possible? Is this possible? Now comment on this, children. Can we have a magnification for a concave mirror of plus 0.5? The magnification produced by a concave mirror is plus 3. We have to comment on the nature of the image. So, how do you do this? Given m is equals to plus 3. What did I tell, children? This plus and minus sign have a meaning and the number will have a different meaning. Since m is positive, what does this mean? Positive, m is positive means the image is always virtual and erect. Image is virtual and erect. Virtual and erect, so where do they form? Yes, correct. And form on the other side of the mirror. And form on the other side of mirror. Okay. Then what does 3 mean? 3 is a number greater than 1. Any value greater than 1 means the image is enlarged image. Since magnification is 3, which implies m is greater than 1, the image formed is enlarged image. The image is enlarged. That's all. So, the two things, the sign and the number will give you two different meanings. The sign will tell whether it is positive image or a negative image. The number will tell whether the image is of the same size, diminished image or enlarged image. This is how you have to analyze the value of the magnification. The magnification produced by a concave mirror is minus 0.75. We have to comment on the nature of the image. Let us do m is minus 0.75. The negative sign of the magnification, it says that the image is real and inverted. Since m has negative sign, the image is real and inverted. And then what is the value? It is 0.75, which means it is lesser than 1. M is 0.75. That implies M value is lesser than 1. So what can you say? If the value is of magnification is lesser than 1, then the size of the image is diminished image. The image is diminished image. The image is diminished image. This is how you analyze children. This is a very interesting numerical, children. At what distance from a concave mirror of focal length 10 centimeters should an object be placed? So they are asking us to find the object distance. That is not a problem, but they gave two conditions. In the first case, we should get a real image which is 20 centimeters from the mirror, and in the second case, we have to keep the object such that we get a virtual image 20 centimeters from the mirror. So we have to find the position of the object such that one time it should be producing a real image and the other time it should be producing a virtual image. Very interesting. Let us solve. What is given? Focal length is given. So f is equals to minus 10 centimeters. Now let us solve for the first one. For the first one, he said the image is real. So if the image is real, what should be the sign of the V? Sign of the V should be negative, and also they are saying it is 20 centimeters from the mirror. So V is minus 20 centimeter. When can you take this V as minus centimeter? Only when you have to solve the first one, not the second one. And then we have F, we have V. Use the mirror formula. From the mirror formula, one by F is equals to 1 by V plus 1 by U. That implies minus 1 by 10 is equals to minus 1 by 20 plus 1 by U. On transposing minus 1 by 20, I will get 1 by U is equals to 1 by 20 minus 1 by 10. LCM of 20 and 10 is 20. So, I can write this as 1 minus 2, which means 1 by U is equals to minus 1 by 20. Take the reciprocal on both the sides. U is equals to minus 20 centimeters. What does this mean? This means that I have to keep the object 20 centimeters from the mirror in front of it. Therefore, object should be placed should be placed 20 centimeters in front of it, in front of the mirror. Which mirror, children? We are doing concave, so in front of the concave mirror. For the second part, it says the image is virtual image. If the image is virtual, which means the image will be formed behind the mirror and it will be based on the positive x-axis, and hence it will have plus side and at a distance of 20 centimeters plus 20. Therefore, again use the mirror formula. Now, even before you start doing this, you should be knowing where you should keep this object now. Since it is forming a virtual image, when will a concave mirror form a virtual image? If the object is placed between F and P, which means the object distance should be less than 10 centimeters here. You should know the concept to get the idea, basic idea at least. From the mirror formula, we know 1 by F is equals to 1 by V plus 1 by U, which implies minus 1 by 10 is equals to 1 by 20 plus 1 by U. So 1 by U, do the transposition, minus 1 by 10 minus 1 by 20. LCM of both the numbers denominators is 20. So when you simplify it, you get minus 2 minus 1, which is minus 3 by 20. Take the reciprocal, U is equals to minus 20 by 3, which means U is equals to minus 3 6 is 18, and then 6.666 something, it will continue. 6 7, so I will round off to 2 decimal. For object should be placed at a distance of 6.67 centimeters in front of it.